Jim, thank you very much indeed, and good evening, everyone. It's a great pleasure to be here as a newly elected Fellow of the Academy, giving my first presentation to the Academy. So I want to cover this evening the engineering challenge that has faced the country, and in particular has faced the Environment Agency since the beginning of December, right through to the present day, and indeed for the foreseeable future, really, in terms of flood risk. Just start by covering exactly what the Environment Agency does in terms of flood and coastal risk management. We undertake mapping and modelling, and I'll cover a little bit of that later. Obviously investing in new flood and coastal erosion defences and maintaining those defences and operating those defences. Warning and informing the public of risks, flood risks, responding to incidents as we've been doing continuously since the beginning of December last year, working with local communities, with the emergency services, with non-governmental organisations, and of course with local government, and a really key partner in managing flood and coastal risks is with local authorities, and implementing government policy and strategy with the funding that government makes available to us, and advising the government in terms of policy development. We have seen record-breaking weather and record-breaking tide levels, groundwater levels and river levels. This is a sort of snapshot on a daily basis from early December through to February of our flood guidance statement. This is published on a daily basis on our website. It looks 3 days ahead, and we provide this information to local authorities looking 5 days ahead. The red indicates significant impacts and a high probability of those impacts occurring. And you can see that there are only 2 days which are green, where we were signalling that there was a low risk of flooding, and those impacts were low, or very low. And that pattern has continued from when this slide was produced right through to the present day, and indeed in our look ahead over the next few days. And Environment Agency staff and teams, working with particularly local authorities but also internal drainage boards and others, have been constantly responding to and planning and looking ahead in terms of the information that we provide through the flood guidance statement. That flood guidance statement came out of a recommendation from Sir Michael Pitt's report following the 2007 floods. And it's a joint venture between the Environment Agency and the Met Office. And we brought together hydrologists from the Environment Agency and meteorologists from the Met Office. We sit them side by side in Exeter, in the Met Office's headquarters. And we're developing a new profession of hydrometeorologists, where we're bringing the expertise of both disciplines and both organisations together to enable us to provide these forecasts that are updated on a daily basis. So an awful lot of science and an awful lot of engineering has gone into producing these, and I think it's quite significant that during the East Coast surge at the beginning of December last year, where some 6 days ahead, the Met Office computer, using models that have been developed for ourselves, indicated that there was potential for a significant surge down the East Coast. And that was long before the depression that caused the flooding had even formed. It was just existed in the computer. And yet that computer model turned out to be remarkably accurate. And I think it's a great testament to the science and the engineering of the Met Office and the Environment Agency and its consultants, particularly Proudman Oceanographic Laboratory, that enabled us to produce such an accurate forecast and give people the necessary warnings. So we had the surge, and we recorded levels in a lot of places higher than the last big surge, which is in 1953. And there are some striking differences. So if you look first at the sort of return periods, and these are our initial estimates, I'm sure they'll change, but sort of North Shields, Whitby in North Yorkshire, about a 1 in 500 year event. come down onto the Humber estuary, Hull, Immingham, about a 1 in 750 year event. Further down the coast, sort of Great Yarmouth, Thames Barrier, interestingly about a 1 in 10, 1 in 12 year event, because the surge coincided more or less with low water than with high water. And then round the coast at Dover, about a 1 in 1,000 year event is our sort of estimate of the return period. And so record levels, and in some places half a metre higher than we saw in 1953. So it's a very significant event indeed. The striking differences are that in 1953, over 300 people lost their lives in England. There was about 25,000 properties flooded, and vast areas of land with loss of livestock, loss of critical infrastructure, electricity, gas, etc. This time, low thousands. We probably think about 2,000 properties flooded, but we estimate about 800,000 properties were protected by the investment that had been made since 1953, and considerably less agricultural land was flooded than in 1953. So it demonstrated that flood and coastal risk management is a long-term business, and that investments made over decades have actually proved their worth in one night, which is what we had in December. And these are just some shots. Boston in Lincolnshire was badly affected through overtopping of defences. There's the Boston Stump, which records historic floods, and it was considerably higher than in 1953. Keedby, this is on the River Trent, it's the tidal Trent. It's about 40 kilometres inland, and it shows you the impact of the floods that far inland. And you can see water overtopping defences. You can see the ships way up above the flood defences, and the building to the left of the ships is a pumping station that we own and operate called Keedby Pumping Station. That pumping station was severely damaged by the flooding incident, and it drains a large area of low-lying land in that area. Some more shots of coastal flooding, again from the East Coast surge. We had river flooding, that's the River Severn at Tewkesbury and Avon. The last time we saw levels on the River Severn that sort of high were back in 2007, and we nearly equalled the 2007 record levels on the River Severn. But thanks to the investment that had been made between 2007 and now, we saw considerably fewer properties flooded along the River Severn. We also had surface water flooding, and that's a shot of some in Staines, and groundwater flooding. And it's really the first time there's been significant groundwater flooding since 2000, 2001. We had some in 2007, but not as significant as now. It is a growing issue, is groundwater flooding. We expect in some parts of the south that groundwater flooding problems will get worse over the next few weeks, and that the impacts will last for up to 6 months. We are seeing in some of the boreholes where we measure groundwater levels in the aquifers, levels higher than we've recorded before and higher than in 1928. So again, it shows the significance of what we've experienced. And that's a shot in February of the storm. So this was a combination of high astronomical tides, spring tides at the beginning of February, coupled with a very deep depression, and we had strong gale force, or storm force I think, winds down in the southwest that were of a southwesterly southerly direction. Jim's already mentioned damage to infrastructure, and in particular the railway line at Dawlish, and there's just a couple of shots to show the impact on infrastructure. This was damaged in February. It's been further damaged by another storm, and I think Network Rail are hoping now that they'll be able to reopen the line mid-April. So that's the amount of time that's going to be needed. And again, that's just another shot which I'm sure people have seen from television. So what was the reason? Wettest January, and Met Office are now saying the wettest winter since proper records began in 1910, but records going back to 1766 show that the last 250 years that this is likely to have been the wettest 2 months. And you can see that the concentration of the rain has predominantly been in the south, which is unusual, and that largely was caused, the Met Office tell us, because of the position of the jet stream, which was influenced by weather in the Pacific. And so it was the weather systems in the Pacific Ocean that was driving the cold weather that the United States experienced and Canada, which then led to the positioning of the jet stream, which then led to these constant storms, one after another, which came across the southern part of the UK rather than the northern part of the UK, which they normally do during the winter period. And that's a shot of both river flows and groundwater, showing that the pink dots are where we've got record levels for this time of year, and the black ones are where it's exceptionally high. And again, it just shows the difference between the north and south of England in terms of impacts. We've gathered together the number of properties flooded. Since the beginning of December, we think it's around 6,500 with water inside properties. There's probably another 2,000 or 3,000 at least that have been affected by floodwater. It's either surrounded them or they've not been able to get access to properties, etc. And you can see the distribution from the East Coast surge in December, and then much more round to the rainfall-driven events, and then the other storms that we had in terms of the tides for the south and the southwest. We estimate that whilst some 6,500 properties have flooded and a few thousand more have been affected by flooding, we estimate between 1.3 and 1.4 million properties have actually benefited from defences, including some very large conurbations. So the Environment Agency has been extremely active throughout this period. We've been cleaning trash screens, we've been running incident rooms, we've been removing debris, we've been erecting temporary defences. I think particular success in early December was at Sandwich, where we're constructing a scheme. It's not yet completed, but we brought in temporary defences, which saved about 200 or 300 properties from flooding from the tidal surge. In Oxford, over the last few weeks, we, and along with the local authority, have erected temporary defences in Oxford. There's been about a handful of properties flood in Oxford. For a similar event in 2003, when we didn't have temporary defences, 120 properties flooded in Oxford. We've been closing barriers and floodgates, and we've been repairing defences, and those two machines are on Chesil Beach. They're basically restoring the shingle that had been swept away by the storms. And the shingle ridge at Chesil that protects Chisel and other places around there is normally 10-metre wide crest. And after one of the storms, it was down to 2 metres. And in some places, we've lost 90% of the material off the beach. With our machines and with the help of the military, who brought in some additional machines, we've been bringing in rock armour to protect the beach, to provide some protection for the storms at the beginning of February. And again, we're back to high astronomical tides this weekend. And so again, we're preparing, it depends on the weather, but we're preparing defences such that we can get them in a state where they'll be able to withstand further attacks and hence protect the properties behind. We've also undertaken a preliminary assessment of the defences that have been damaged around the coast and inland. At the moment, we think about 750 assets have been damaged. That's Environment Agency assets, local authority assets, and there'll also be some internal drainage board assets in there as well, and some private defences. And we're drawing up a plan, a programme of work to repair them. we've already carried out emergency repairs, and further repairs will be needed over the coming months. And the government announced an extra £130 million to help us repair damaged defences, 30 million this year, 100 million next year, and we're already underway with those repairs and planning further repairs next year. The Thames Barrier, an iconic structure, protects central London and its associated defences, because it's not just the Thames Barrier, there are other barriers. In fact, there are 9 major structures that need to be closed on high tides, and all the defences associated with those. It's some 30 years old, is the Thames Barrier, and I think now we've had 165 closures of the Thames Barrier since it was built. A quarter, 25% of those closures, was within the last 3 months. So it's really proved its worth in terms of providing protection to London, and indeed we've also been using the Thames Barrier in terms of providing protection to properties upstream of Teddington, given the high flows that have been coming down the Thames. And we've done some preliminary work to assess the volume of flow over Teddington Weir, which is the tidal limit of the Thames. And initial indications are that in a sort of month period, we've had the highest flow over Teddington Weir since the 1800s. So it's not been a record level on the Thames everywhere, although we did exceed the 1947 level in a couple of places. But in terms of volume of water, back to the rainfall that we've experienced, very significant increase in flow during that period. As well as barriers, we've also got flood storage reservoirs. We've 2 here in Kent. The Lye Barrier, it holds about 5.5 million cubic metres of water. It was full over the Christmas period, and regrettably there was some flooding downstream, but the barrier itself saved the High Street in Tunbridge from flooding. And before the barrier was built, then there was 6 foot of water in the High Street in Tunbridge in previous events. And since the barrier operated, we've reduced the number of properties flooding very significantly. And again, just near Ashford, just literally a couple of weeks ago, the Ashford Reservoir did reach its full capacity. But again, by sandbagging properties downstream and doing other measures, we were able to protect those properties from flooding. A number of our defences, new defences, have worked in these events, and therefore we've already got back the investment that we've made in them. 2 really good examples in Warrington, a scheme that protects Warrington from tidal flooding from the tidal Mersey, and again early December, very recently completed scheme, phase 1 of the scheme, protected some 800 properties from flooding. And you can see the water up against the defences. Without those defences, there would have been major flooding within Warrington. On a smaller scale, but no less important, Upton-on-Severn in the West Midlands, then a scheme that was completed following the devastating flooding there in 2007. And again, Upton defences have worked, and the local community is extremely happy with the defences that we provided since 2007. That was the first really major test. Somerset Levels, still flooded, and has been flooded since sort of early December, and that follows the devastating flooding that there was in 2012 on the Somerset moors and levels. That was a shot in January. The levels were flooded significantly more in the early part of February, given all the rain we had at the end of January, beginning of February. We are working with the local authorities, with the emergency services, with the military, to pump out water as quickly as we can from Somerset moors and levels. It's the largest pumping operation that we've ever undertaken in Somerset. There are 40 permanent pumps. Some of those pumping stations date back to the 1930s, the 1940s. And we brought in another 30 temporary pumps. Some of them have come over from the Netherlands, the Dutch pumps. We estimate that there's about 92 million tonnes of water to remove from the moors, and that our maximum pumping capacity is about 3.7 million tonnes per day when river levels permit. And it is a very, very complex problem dealing with the Somerset moors and levels, and in particular the pumping strategy. If we pump too early, then basically all we're doing is pumping water round, because we're pumping it back into the river, it just comes back over into the moor. If we pump in the wrong part of the catchment, we can make matters worse elsewhere. And so it's a combination of local knowledge that's been gained over many, many decades, using the available pumps, and bringing that local knowledge to bear to make sure that we can evacuate as much water as possible and as quickly as possible. And the key factor, of course, is that it stops raining. We've had a good week so far, and we're hopeful that this week will be equally as good. In some of the moors, we have now reduced water levels by 0.5 metre. And so we are making significant progress. In other moors, we've not been able to start pumping until in the last few days, purely because of this problem of just pumping the water around. But a significant operation underway, and that will continue until we've got rid of the water. MICA is our mechanical, electrical, instrumentation, control and automation teams. They are at the heart of all our pumping, all our response in terms of generators, in terms of making sure our barriers operate and work, complying with all the health and safety regulations that we have to do, and in working with others. And I think in terms of an engineering response to the floods, then the MICA teams within the Environment Agency and our contractors, it's been a fantastic effort, because they have made sure that everything has worked and they've kept things running. And when we've had issues, they've responded very quickly. I mentioned earlier about the surveys that we're doing in terms of asset damage. These are a couple of shots showing some of the damage to our flood banks along the Humber estuary and to some coastal defences belonging to a local authority, where you can just see the sort of power of the waves and the overtopping and the force of the waves that caused massive, great big sort of concrete revetment to move. We are training 200 soldiers this week, along with Environment Agency staff, supported by consultants, to inspect all the assets that have a flood risk management purpose across England over the next 6 weeks. So it's not just Environment Agency assets, but local authority, Internal Drainage Board and private defences. And it's to answer the strategic question, what is the state of the nation's flood defences, given what has happened? And we'll be able to give that advice to government, we think, in about 2 months' time, once we've analysed all the data. So that's a major asset inspection that will be starting very soon. The training's taking place this week. There was a lot of engineering went into the repair of defences. This is one example on Teesside, a place called Seal Sands. Very large industrial area protected by these defences. The December surge knocked a hole clean through one of them. First of all, we sought military assistance with Chinook helicopter to stabilise the breach of the defence as an initial response, and then using our own staff, consultants and civilian contractors, we've built a road out of stone to the breach and repaired the breach. And so far that has withstood the tidal surges that we've had since then. We'd still need to do a permanent repair, but in terms of a temporary repair, that has been extremely effective. and the industrial chemical company that owns the site that's protected by this defence had to cease operations, which had a significant economic impact on Teesside, and those operations have now resumed. So that has been a success. I want to now sort of move on to some of the science and engineering behind some of the mapping that we do. We're using techniques, LiDAR techniques, from aircraft, where basically you're firing a signal down to the ground, getting that signal back, and then we can, using fancy computer programs, we can convert that into topographical information and use that with our models to produce flood maps, which are available on our website. This information is also made available to the insurance sector. So you can type your postcode on our website as to where you live or where your business is, and you can see what risk you are at from flooding. And we've just recently published some new flood risk maps at the beginning of this year, which again provide a more risk-based approach to assessing flood risk. And again, that information is all available on our website. And for the first time, we published not only new maps in relation to risk from rivers and the sea, but also from reservoirs and from surface water flooding. And to our knowledge, it is a sort of world first at a countrywide level to have published risk maps of surface water flooding. Another key aspect in relation to managing flood risk is our warning and informing. And we have a number of sites right across England where we're measuring rainfall, we're measuring river levels, tide levels, we're measuring flow, and we're measuring groundwater levels. And our hydrometry and telemetry monitoring network is basically the intelligence gathering that we use to inform our warning and informing service. We have over nearly 6,000 telemetered sites, and that information is available in more or less real time, again, through our website. So if you go to our website, click on river and sea levels, you'll be able to get more or less in real time information in terms of river levels, sea levels, and there are a few groundwater levels as well. And again, there's an enormous amount of science and engineering behind that in terms of collecting all that information, validating all that information, using it in real time, using it to drive models to help us to give better forecasts and warning, and then archiving that information so we can use it and others can use it for designing new schemes. One of the sort of new innovations, and it was mentioned earlier in terms of whether people would be tweeting this meeting, is the use of social media. And we have found social media extremely helpful in terms of getting information out to the public. We have used for the first time this Twitter alert system. So that came into operation in October, and we were the first organisation to use it, whereby we can send messages and Twitter will send those out on our behalf in terms of warning of flood events. We're working with a company called Shoot Hill, and again available through a number of applications and also now through Google. Then you can get this information in terms of where our warnings are, and we're also on Facebook, so we are using that information. We're also receiving information from people who are sending us information on flooding that's happening in their area. And that's extremely valuable to us in terms of our local teams. And again, when we're responding to flood events, then again we're able to give reassurance to people that we're cleaning their trash screen or we're operating their floodgate, and we can basically put that information out in real time and show photographs of what we're doing. So looking forward, then I think the challenges around how we adapt in terms of climate change, because the predictions are that we will see more of these types of events we've experienced over the last 3 months in the future. And our Thames Estuary 2100 strategy sets out an adaptive approach to managing flood risk on the Thames Estuary, and we'll be using that experience in terms of adaptive approaches elsewhere, particularly on other major estuaries. And then also working with natural processes, so looking to work with nature rather than against nature, looking at how land use change can help manage flood risk, storing water in upland areas, and the shot there is of an example in Northumberland, and looking as to where we can realign the coast. So we're getting a win-win situation. We're reducing flood risk, and we've got a really good example on the Humber estuary at Alkborough. It was a scheme that cost about 10 million. It's created a large flood storage area, which was operated during December, and it reduces flood levels on the Humber estuary by about 6 inches, which has saved us about 30 million in terms of what it would have cost to have raised our defences by that amount. So you get a really good return on the investment, and you also get a wildlife habitat in that area as well as an additional benefit. So that concludes my presentation, but I'm very happy to take questions, and I think we're going to come back to here, aren't we, Jim?
Thank you very much indeed, David. Yes, we have about 40 minutes for questions and discussion. And I think there should be some microphones around the place. So if you'd like to ask a question to David, please raise your hand and introduce yourself. Over here.
I'm Jeff Lohmer. I wonder if you could tell us what criteria you will be using to decide where to allocate that 130 million, I think you said, on additional defences will be. Is it to do with numbers of properties, whatever criteria you have?
I think let's take them one at a time and see how we get on.
At the moment, what we've been able to identify up to the middle of January in terms of damage to defences is an assessment of the costs. And we shared that with the government. They've given us the funding to enable us to carry out those repairs that we've identified. They are predominantly repairs to tidal defences, given the severe damage that's been caused. We know that since the middle of January there's been further damage to those defences and to other defences, so newly damaged defences, and at the moment we're assessing what those damages are. We're getting information from local authorities in terms of the damage to their defences, and then we will need to have further discussions with government in terms of any additional costs that may arise out of that. There are some parts of the country where defences have been damaged that aren't protecting property, and so our priority has been on getting defences repaired on an emergency basis that protect property. And we will need to have further discussions once we've gathered the information on those defences that just protect either agricultural land or important habitats. And that work is still ongoing.
Thank you for a very interesting talk. I'm Dougal Goodman from the Foundation for Science and Technology. One of the issues raised in the pit review was the question of protecting critical infrastructure like water treatment works or electricity substations. To what extent is the Environment Agency responsible for that rather than the utility? And I have a second simple question. Is there a cost-effective replacement for the sandbag?
Well, let me take critical infrastructure first. It was a PIP recommendation, and we've been supplying to utility companies information in terms of flood risk. We've also got specific arrangements in terms of specific warnings to operators in terms of floods that may be happening. So we've got specific warnings in place, particularly with the electricity supply industry, but also with the water industry. And there has been significant investment by utility companies to protect their assets. And I think a good example is the Mythe Treatment Works at Tewkesbury, where in 2007 that was put out of action, and yet not dissimilar flood levels we've experienced over the last few weeks. The investment that Severn Trent Water made at that site has protected, which meant that the supply has not been interrupted in any way. We also had a good example near Gloucester, where again in 2007 a substation was flooded, this time with similar sort of levels. That substation wasn't flooded. So the government gave advice, the Cabinet Office published advice following the PIP report in terms of protecting the nation's infrastructure and set out policy advice within there. And I think utility companies have followed that advice, and so the country is more resilient. But there have been some examples, and Dawlish is one, I think Immingham Docks is another, where there was significant flooding, and we're working with the government in terms of reviewing the risks the country faces to infrastructure, and then the government will, I'm sure, be giving further advice to those companies. In terms of sandbags, then yes, there are alternatives available, and I think the temporary defences that we've been using, I showed a photograph of that we've used in Oxford, we used in Sandwich, have been extremely effective. And the thing about temporary defences is that once you've used them in one place, once the risk has gone, you can then just put them on a wagon and take them somewhere else and use them again. So I do see over time that we'll use less and less sandbags, and we'll use more and more of these types of temporary defences in the future.
A question in the front here, and then one over there in a moment.
Hi there, Jonathan Leake. I'm the environment editor from the Sunday Times. Two questions, really. What would have happened to London were it not for the Thames Barrier? And secondly, the early part of the floods was marked by a lot of very strong criticism of the Environment Agency, which I thought personally was quite misplaced. And I was wondering what you thought of the quality of the political debate and response to those floods, and the quality of the response in the media, and how the Environment Agency might be able to help improve that in future.
In terms of London, then without the Thames Barrier, I think we would have seen, and its associated defences, we would have seen significant damage to London, and in particular to the financial sector. Canary Wharf is in the floodplain, and that's why we're able to justify an extremely high standard of protection for central London. London is still at other risks of flooding, and in particular surface flooding, which will need to be managed should we get a certain heavy rainfall over London, which would still, I think, cause significant problems. But in terms of tidal risk, then the barrier does protect London, but without it, there would have been significant flooding. In terms of the Environment Agency working with government, we are working extremely closely with government. I've been attending virtually all the COBBLE meetings and giving advice to the government at the highest level, right through this flood event. And so the whole machinery of government has come together to help people and their property that has been flooded. And obviously our sympathy goes to all those who have been flooded, and particularly to those whose houses are still flooded, because significant number are. I think we can improve the way that we communicate, and part of today is about that, and other events that have taken place, so that there is an understanding in terms of the risks that people face, what they need to do to manage those risks, and then it becomes a question of how you then determine what is an acceptable level of risk of flooding. And that has to be a political question that the government of the day must decide.
Question here.
Thank you. Gwilym Roberts, very much retired now. Dawlish, I understand from the press that Network Rail are considering various alternative inland routes. How feasible is it to put in a robust seawall, say 30 metres,
seaward of the railway line and preserve the existing line in all circumstances?
Well, those really are questions for Network Rail. I do know they are looking at options, and I do know that they are undertaking repairs as quickly as they can. And I think it was a very good move on their part to bring in the containers that they filled with rock to provide some temporary protection, because the second storm, without that temporary protection, would probably have taken out some of the houses behind the line. And so by putting in that temporary protection, they buffeted some of the waves. There was significant further damage, but at least it hasn't led to collapse of property. So I do know that in discussions I've had with Network Rail, they're absolutely focused on getting that line open as quickly as they can, and they're hoping to do that by mid-April.
There may be a coastal engineer or two in the audience who might very quickly wish to comment on that. William.
William Alsup, Wallingford and Southampton. I was in Plymouth last week actually presenting to the university on the failure of seawalls and on Dawlish. The tragedy of Dawlish is that it's absolutely not unexpected. In 2003, I did some work for a railway company who had deployed a wonderful new overtopping detector. They ran a train that was uniquely configured to trip out and stop when immersed in salt water. The tragedy at Dawlish is that everybody else has sat on their hands and let Network Rail and Railtrack take the flak. That wall has collapsed a number of times. Indeed, at that site, it's failed at 2 previous occasions. The strengthening works that have gone on have addressed a particular and concerning failure mode, which is scour undermining the wall. Sadly, they may very well have increased overtopping and the forces on the wall. And the calculations that I and some colleagues did suggest that the height of the 5th of February storm overtopping was about 10 cubic meters per meter run at its peak, travelling at approximately 20 to 30 meters a second, and so you wouldn't be surprised at forces, which I think are an underestimate of 500 kPa on the top. Sadly, none of that is all that new from what I calculated in 2003. And until a lot of other stakeholders actually participate in the problem, then the railway company will carry on addressing their one concern. You'll never get a holistic solution. Sorry, that's a long one. There is there'll be a PDF available on the lecture I gave in Plymouth if people want.
Thank you. Yes.
Oh, thank you. Keith Clark, a Fellow of the Academy. My question is, to what extent is wildlife preservation given absolute priority in your decision-making? You have on your slide, the final slide, and by the way, thank you for an excellent presentation, working with natural processes, and that is obviously very sensible indeed. No one would argue with that. But there are a number of points that lead me to ask the question. First, when you stopped dredging in the 90s, there was not a financial crisis, and there was not a lot of focus on climate change either. And the reason given was to encourage weed growth in the rivers, because that supports more wildlife. It is also a fact that there's a number of very influential bodies are advocating the reflooding of the fens and of the lowlands, not because it's inevitable with climate change, but because they are antipathetic to modern farming. So if it's a policy objective to flood the fens, you need to be clear on what your objective is. And my final anecdote relates to, I think, some of your engineers found a badger set in a vital flood defence. They were told they couldn't repair the badger set until the badgers had been humanely trapped and moved to a new badger set and were breeding again happily. And whilst that was happening, DEFRA was shooting badgers by their 100 to stop the spread of tuberculosis, which doesn't actually seem to like joined up government. So the question is, to what extent does wildlife preservation have absolute priority, given that you must obviously work with natural processes, if that makes sense?
I mean, our priorities are very clear. And the first priority is life, protecting people's lives. The second one is protecting people's property. And then the third one is protecting the environment. And we have to comply with environmental legislation in the same way as any other organisation involved in flood coastal risk management would have to. And so there are environmental laws that we comply with. But we've shown, I think, working in all parts of the country, that we can achieve those outcomes in terms of protecting people's lives and their property at the same time as not damaging the environment, and where we can improve the environment. In terms of dredging, then for the Somerset Moors and Levels, we always said that dredging was part of the solution, but other measures would need to be taken as well. And in particular, we need to look at whether a barrier across the River Parrett would help. And we've done some initial studies around all of that. And looking also at the catchment. And are there solutions that take a catchment-wide approach, which would provide flood risk management benefits? And with the money that the government has announced for dredging in Somerset, then last week we were announced that we were letting a contract start that dredging as soon as it's safe to do so, and then we'll be looking to undertake a major dredge once we've got all the approvals in place later this year. And so that work can now start now the funding has been guaranteed. In terms of the specific around particular animals, and badgers being a good example, then badgers and badger sets are protected by law. We do work closely with Natural England, who administer and enforce that legislation, and that enables us to do the necessary works, but we've obviously got to do them in such a way that we comply with the law and with the requirements of Natural England. And I can think of many examples of where we've done that successfully.
Question in the front here.
I'm Robert Webster, I write for Carbon Brief. In their last slide, you gave us sort of one page on future responses to climate change. And I just wondered if you might be able to draw that out a little bit more, given that we're sort of facing a world maybe in 20 or 30 years' time where these kind of events are very likely to be more frequent, possibly even more severe. I understand what you're doing with one river from what you said, but it would be interesting to hear more about what the kind of plans are with government on this.
If I take the Thames Estuary as being a good example and just go into a little bit more detail, then with the flood risks that face London, and we just talked about that earlier in terms of the damage that would be caused, I think there's something like £200 billion worth of damage would occur if there was a serious flood event in London. Obviously a major impact on the economy. Then what we're doing is this adaptive approach whereby we've looked ahead over the next 10 years as to what needs to be done. We're looking ahead over the next 20 to 50 years and then right through to the end of the current century. And we can adapt the responses that are necessary and the investments that need to be made. So if you take the Thames Barrier as being a good example, at what stage do we need a new Thames Barrier? And the current Thames Barrier was designed to 2030, its designed life. Having looked at it, with further investment in the existing barrier, we think we can extend its useful life to around 2070, based upon current predictions of climate change. If in the intervening period, climate change turns out to be more severe than what we're predicting, then we can bring forward the investment decisions for what we do in terms of a new Thames Barrier. If, however, climate change predictions are not as severe as what's currently predicted, we can push back those investment decisions. And so we end up with this adaptive approach, whereby we're making timely investments in necessary infrastructure based upon the best science available at the time.
A question at the back here, two at the back, in fact.
I've got a graph here by a book by Kevin Smith.
Do you mind introducing yourself?
James Aratoon in the IET. water in Britain. And Professor Hall mentioned the long-standing history of measurements at Oxford, and I can show this graph to everyone here if they want to see it. It shows that the recurrence interval and the slope for rainfall events in 25-year periods for rainfall totals exceeding 1 inch at Oxford. And the slope is generally increasing. So if between 1881 and 1905, for a recurrence interval of 40-year events, which was about 2 inches of rain, that moves on to the latest slope at 1941 to 1965 of about 4 or 5 years. So in a 60-year period in the Oxford data, we've got change of 10 times in the recurrence intervals. So it's quite a big variability going on, and this is the long-standing data. And this is the problem. How do we predict with this sort of level of change? I'll just give you just the slopes are quite considerably changing over the period. And this is the problem. How do we predict with this level of change over a period of 60 years?
I think you've highlighted a really interesting challenge for us in terms of, in an uncertain future with climate change, that our predictions are based upon the historic record, and are they still valid or not? And if they're not valid, then what data do we use in terms of future predictions? At the moment, what we're doing is we're building into the design of our schemes allowances for climate change based upon the best science available at the moment at the time. But going back to our adaptive approach, for major infrastructure like the Thames Barrier out in the future, then we can wait till the science improves. For some of our defences, like the scheme I showed at Warrington, and we've built in the best estimate from the government's advice in terms of climate change. And thank goodness, when the Thames Barrier was designed, that its designers made an allowance for sea level rise and land tilt in the southeast, and that enables us to still operate the barrier at its design standard for the foreseeable future. So it is a real challenge for us, but at the moment we're building in an allowance. Time will tell whether that was sufficient or not.
Question at the back here.
Peter Herford, I'm a fellow of the Academy. In 2006, I was working for London River Services, a branch of Transport for London, and there was an exceptionally high tide in central London in December, so much so that it did damage to the infrastructure of Millbank Pier. When we tried to find out why the barrier wasn't closed, we were told that it was a failure of forecasting. And although you gave a very comprehensive answer just now about the future of the Thames Barrier, my question really is about the resilience of the Thames Barrier, about the models you use to forecast its operation. I would ask a question too about its reliability. You've got about 6 controlled openings, I think 6 or 7, and with a reliability that has that the thing is designed to operate at, are they individually good enough? And I think too, the last question is, I believe it was designed to withstand a tidal surge 1 in 1,000 years. You had that in Dover this year. Now, obviously, that's not to predict, but clearly the trend is a frightening one. And you mentioned these models which will govern the further investment in the barrier and indeed the creation of perhaps a new one farther out. Given this, the enormous damage to London that would occur, are you confident that there is resilience in all these issues?
We are confident that there is resilience. When the barrier was designed and built, then there were backup systems provided, and there were backup systems provided to the backup systems. So there's 3 levels of protection in terms of the design of the barrier. We're investing in the barrier all the time. So as things have come to the end of their useful life, we've replaced them. We've undertaken studies to look at what is the probability of failure in terms of if we press the button to operate the barrier, it works. And we've had that independently verified. There is a group of experts around the world that operate large barriers like the Thames Barrier. There's one in the Netherlands, the Rotterdam Storm Surge Barrier. There's one in Russia. There's others. There's a few around the world. And we have a really good network whereby we go to do an internal independent audit of their barriers, and they come and do the same to the Thames Barrier. So we are getting experts who are used to operating barriers, checking each other's barriers, setting international standards. And what we're doing is we're rolling out that best practice across all our barriers, not just the Thames Barrier in England, so that we start to get a real learning in terms of what could happen. You can always get problems. I mean, we had a delivery of gravel to the Thames Barrier that we didn't order when one of the ships crashed into one of the piers and deposited gravel on one of the gates. But you know, by prompt action, we managed to get the gravel removed. So there's always that risk that something totally unseen can happen. But in terms of the resilience and the redundancies that is built into the barrier, we're confident that it will operate when it needs to operate and protect them.
Tim.
Thank you, David. In and around the A22 at Kenley in North Surrey, there have been some quite significant disturbances to road, rail, water infrastructure over the last few weeks by the emergence of a bourne. Is this becoming a general issue around the UK, and is there anything like a generic strategy of dealing with these sort of intermittent, very infrequent rivers?
We have groundwater warning alert systems in place, and those alerts have gone out in terms of warning infrastructure operators, warning the general public, warning businesses in terms of risk of groundwater flooding. We're working with the British Geological Survey and with the Centre for Ecology and Hydrology in terms of reviewing the total risk of groundwater flooding across England at the present time, and providing advice in terms of looking ahead as to what those groundwater risks might be over the coming 6 months. And Kenley specifically, then some works have been undertaken in terms of additional pumping. Temporary barriers have been installed. The warnings have been issued to businesses and properties downstream, so that the risks have reduced considerably in terms of either loss of supply from Kenley or in terms of flood risk to the community downstream. But with record levels that we are seeing, and one of the record levels we are seeing is around the Kenley area in terms of water in our borehole, then those risks are increased, and they're more severe than we've experienced probably over the last 60, 70, 80 years. And so we are trying to develop with the British Geological Survey the science to enable us to have better predictions in relation to groundwater, because it is not as sophisticated as it currently is for river and sea flooding.
Jean.
Jean Venables. I run the Association of Drainage Authorities because 1/10 of England and Wales is actually under managed drainage. They live below the adjacent river level or below the adjacent sea level. And because these have operated for hundreds of years, we've got an awful lot of infrastructure. We've got 53% of our electrical generating capacity built inside those areas, a lot of road and rail infrastructure as well. They do depend on an outlet, and the problem is that the outlet is often in a main river, and that is what's happened down in the River Parrett, in that we're not talking about Somerset flooding, we're talking about the River Parrett catchment flooding, because the adjacent catchment down in Somerset is not flooding, the Axe and the Brew, because that has got an outlet. The problem we've got down at the River Parrett is that it doesn't have an outlet to get rid of the flow. And that comes about because the Environment Agency runs out of money before it gets to the bottom of its job list, in that there is insufficient funds, and also the way in which policy directs those funds to be spent on protecting properties which means that therefore large conurbations get priority, and these other schemes never ever come up to being done. How are we going to get more money to maintain the services that we've already got? Because each time you say to the government that the maintenance money is decreasing, they say the total money that we're spending on flood risk is going up. That is not the same as saying the maintenance money is going up. Maintenance money is going down. And if we're building more capital works, we need more maintenance money to look after the works we've got. And I think it's very, very short-sighted that this country is actually reducing its investment in its flood defences and its flood risk management. And how do we actually help the Environment Agency have more money to do the work that needs to be done? Because otherwise Somerset is going to happen in other parts of the country. We're very, very fine edge on other parts of the country. So I'm really concerned that the Environment Agency has done a good job with the amount of money it's got, but as a whole, this country is not spending enough money, particularly on maintenance. And is all of that extra 130 million going to be allocated for capital? How do we help you, David?
Funding is clearly a matter for government. Our job is to make sure that we get the greatest return that we can in terms of the investment, and do it in the most effective and efficient way that we can. So of the 130 million, then of the 30 million for this financial year, it's 20 million capital, 10 million revenue. And for next year, the 100 million, there again is some amount of revenue, but most of it is for capital. In terms of capital investment, and particularly in terms of major infrastructure or indeed a major capital dredge, then the government's policy of partnership funding enables the government to put in through ourselves money that provides national benefit, and it enables local people and local organisations to put in money that provides local benefit. And local people, if they want a higher standard protection than can be normally justified, if they're willing to pay for that, they can pay for that higher standard of protection. If they don't want to contribute as much for a certain standard of protection and they're willing to live with the risk, then they can reduce the cost and just put in a smaller amount of money and accept a higher level of risk in terms of that investment. So I think on capital, the government's policy that we implement on their behalf is very effective, and we've managed to generate, either through money we've already raised or money that has already been agreed, over the period of the spending review, an extra £148 million of investment, which clearly will provide a significant benefit and a significant local benefit to match the money that we've been allocated by the government. But on the revenue side, then that comes under Treasury rules, and clearly the level of funding is one for the government, it's not one for the Environment Agency.
Brian, you know. Roger.
Excuse me. I'm not sure we can easily do a lot in terms of influencing politicians on how they spend their money, but I agree with Jean's points. But I would like to turn to a point, if I may, where I think we can make a change. And that relates to a fact that the Joint Board of Moderators decided about 5 or 6 years ago that they did not require fluid mechanics, hydrology, water basically to be included in an undergraduate course. Now, you talked about the models, David, and I know how dependent upon those models you are. And we really depend on young, very capable people with a good grounding in fluid mechanics, hydrology and so forth on these courses. And it's always worried me that we're now seeing more and more courses cut back on the fluid mechanics, introducing more BIM and so forth. So we're going to get more and more graduates coming out with no knowledge of fluid mechanics. They don't have to have any fluid mechanics or hydrology. Should we, perhaps through the Academy, be putting pressure on the Joint Board of Moderators to put fluid mechanics back in undergraduate courses as a requirement for JBM accreditation?
We as the Environment Agency would very much support that. Because we rely upon experts and being an intelligent client in terms of being able to commission models, being able to understand what those models are doing, the limitations of those models, and then to be able to use them in an operational way.
There's a question at the back.
Cyril Valifontaine from the French Embassy. Did you give advices to the local community for building areas or villages? Have these advice been followed? And do you intend to change your advisory policies, taking into account what happens this year?
Okay. So I think the question is around what advice do we give in terms of development in the floodplain. And we follow government advice, which is very clearly set out, and we give advice to local planning authorities in terms of risks to flooding of developments. And in 98% of cases, then our advice is taken on board by local authorities. In the 2% where it's not, then either local authorities proceed with the development or it goes to appeal, and inspectors on appeal allow the development. And so there has been significant success because we're now at 98%, we used to be much lower than that. And so I think a combination of the advice from the government, our influence with local planning authorities has made a difference. But for the 2% of cases where our advice is not taken on board, then it's a matter for politicians in terms of the decisions they take into account our advice, but everything else that they need to take into account. I think our concern would be around the cumulative impact over time of all of those 2% on an annual basis, because it does add up to increased risk. But it has to be a political decision. Our job is to give advice, and then the politicians can decide in the light of that advice.
A question over here.
Yeah, Alex Braun. With obviously a huge amount of this rain coming down on us, landing on farmed land, how much consideration do you think is required on modern farming practice and the use of the land in, because I see there, in storing of water up land and things, the absorption of the land in relation to new machinery and practices and things which are happening? How, is this something which is being, we talk a lot about drainage and rivers and dredging, but what about the actual, the ground itself?
I think there are two things there. The first one is the protection of agricultural land from flooding. And our defence is not only protected property, they've actually protected large areas of agricultural land, significant areas. And the investments that we've been making in a number of schemes each year provide not only benefit to property but also benefit to land. There has been flooding of agricultural land. We think it's about 2,500 square kilometres of land that has flooded. Some of it has flooded from the sea, and clearly there will be a long-term impact because of the salt that's now gone onto the land, particularly around the Wash. There was quite a lot of land flooded in early December. In terms of, so the investment we're making do provide for. The other issue is around land drainage and the productivity of the land. And our responsibility has been around providing protection against flooding to agricultural land. Historically, our predecessors provided land drainage services as well. And a lot of our pumping stations provide a mixture of the two. So it does become quite complex in terms of assessing the benefits from avoiding the land flooding and the benefits from land drainage of increased agricultural production. But some of that infrastructure was put in the 1940s, 1950s and 1960s is coming to the end of its useful life. And there is a real issue in terms of justifying, on a pure benefit cost approach, investment in land drainage infrastructure against investment in protecting people and their property and their businesses. So under current policy, then the solution is as long as it is cost beneficial, meets the Treasury rules on benefit cost, then it's back to the application of partnership funding. But the amount that we can put in on behalf of the government for purely agricultural land flooding will be quite small. And therefore it will need landowners themselves, or local authorities, or internal drainage boards, or others, to make a larger contribution to enable specific land drainage schemes to go ahead.
Yeah, just to add on to that as well. But do you think the actual way or a change or different things of the actual land is used could help reduce flooding levels by making the land more absorbent to hold water back? Or I read, I don't know who it's from, I read a thing, it's quite a couple of years ago maybe, someone was trying to do a study, I think in the late 60s, early 70s on soil, water runoff on soil. And they said when they tried to do this study in the, I think it was the late 60s, they struggled to find an example of this runoff. They were going around, there was no real areas of runoff. But now you can drive around and it's quite clear to see patches in fields where all the dirt is the rain and things due to maybe the compaction of the soil under the surface. You see lots of more examples of this. So obviously with maybe the techniques or the conditions, these things have changed. But these vast expanses of land we have available, could they be used in some way if you know, to try and alleviate the problem?
I think it will be part of the catchment approach.
If you can, David.
So we will have to look at all means. You know, it's going back to the point I made earlier about Somerset and the northern levels. Dredging is part of the solution, it's not the whole solution. And certainly we need to look at the barrier to stop the tide coming in, but we also need to look at land use change in the catchment, where there are flood storage reservoirs, like the two that I mentioned, and we're deliberately flooding agricultural land to hold water back, and we do pay farmers compensation for that. So I think it will be one of the means by which we'll be able to manage flood risk in the future, particularly in the face of climate change. But we do need better science. Studies are being done at a field scale and at a very small catchment scale, which shows that land use change does have an impact on floods. We've not yet got the science that has been able to scale that up to a large catchment scale. And there is work ongoing, but we're not there yet.
Thank you. We must draw things to a close, but there'll be an opportunity for further discussion over a drink in a moment. But thank you very much indeed, David. After the 2007 floods, the pit review looked at the lessons learned from those floods, and it's clear that a great deal of progress has been made, both in the way in which floods are managed. We saw about the Flood Forecasting Centre, the use of temporary and demountable offences, the management of these emergencies, and also the ways in which the Environment Agency is investing in a range of different strategies, and amongst them flood defences. So engineering is making a huge difference, and we are learning lessons. It's also clear that engineering is cost beneficial in a very big way. So benefit cost ratios easily in the range of 8 to 1, for example, David. So these are investments which yield genuine returns in terms of risk reduction for the country, in terms of impact upon people's lives, in terms of disruption to infrastructure and the economy. And so that case needs to be made very strongly. I think the other thing which has come through very strongly is that there are many different things that need to be done. Some of the media coverage around these floods has been rather polarized, focused upon the dredging or catchment rewilding. In fact, we need a systems approach which looks at a whole range of measures, plans them and implements them in a staged way through time and in a way which can be adapted to a changing climate and other circumstances. And David, this evening, I think has demonstrated very well the work that the Environment Agency has been doing to achieve that. So thank you very much indeed.